Hello, everyone, and welcome to the ADVizE mini lecture, Teaching Graphing and Graphs. I'm Kristen Hunter Thompson, and let's jump in. Sorry, got ahead of myself there. Like always, before we really dive in, let's pause and do a little bit of reflection on graphing. So, how did you learn how to make a graph? When do you remember first making a graph? And what did you learn how to do in order to make that graph? Okay, pause, think about that a little bit, and then come back and join us. So, this might not have been what you expected for our first slide of this mini lecture. And I'm actually going to encourage you, if you want, to pause again, go to this YouTube link, watch this 7-minute video of Charlotte and Daniel playing the piano. It is beautiful to listen to and really fun. We're not going to do that during this mini lecture, but I encourage you to do it if you'd like. What I am showing you are the results of eye tracking study that was done that the video talks about, where they put eye tracking software, those are glasses that track where your eyeballs go, on both Charlotte and Daniel. Now, Charlotte in this instance is the novice, Daniel is the expert, though I would like to say that Charlotte is studying to be a professional pianist. Therefore, she is much less of a novice than my 3rd and 5th graders as they are learning how to play piano. But with that caveat, in this instance, Charlotte is more of the novice. Daniel has been playing for a lot longer. He is more of the expert. And what they were asked to do is they were asked to each play a piece that they knew, and then they were asked to play a piece for the piano that they had never played before. And what we are looking at are the results of that eye tracking once they were playing a piece that they had never played before. So Daniel spent 83% of his time looking at the sheet music and only 17% of his time looking down at his hands for this piece that he had never played before. Charlotte, playing the same piece that she had never played before, spent 58% of her time looking at the sheet music and 42% of her time looking down at the piano. So there's a difference in where they're like how much time they were spending looking in different places between the expert Daniel and the novice Charlotte, as well as there is a difference as to physically where their eyes were going. So here we're looking at a heat map. The red is where there's more frequency and green was less frequency, and where there are no colors, their eyes did not go. So what we can see is that Charlotte had a much wider visual range when she was looking down at her hands than Daniel did when he was looking down at his hands. So why am I sharing this? Because this is really important and helpful to know as facilitators of people's learning with data visualizations. When we are an expert versus a novice, our eyes go to different places. Literally, we see, spend time, and pay attention to different things as a novice versus an expert. There are also some other key things that are different that are going on inside of our brain when we are a novice versus an expert. So when we are a novice, we notice surface attributes. This is true for whatever we're working with as a novice. We're going to think about it as it relates to data and graphing and helping our students with graphing and making sense of graphs. So novices notice surface attributes, whereas experts notice features or meaningful patterns in something. So here we're looking at some data from black sea bass. It's a kind of fish that is found off the eastern seaboard of the United States. I do not think in latitude, but this is plotted in latitude. So I put in these state abbreviations. So this is about the latitude of North Carolina, and this is about the latitude of New Jersey, in case that's helpful. And what we're looking at is we're looking at the central location for black sea bass in the Atlantic Ocean over time. So from the mid 1960s to the mid 2010s. And each dot represents scientists went out into the ocean and they recorded where they found black sea bass, and then they averaged that all. And that dot is the average latitude where black sea bass were found for each year. So our novice would look at a graph like this and say something like, it goes up and down. Whereas as an expert, we, yes, see the up and down, But we also see that overall, there has been this increasing trend over time. And that black sea bass went from predominantly hanging out around the Carolinas to predominantly hanging out around New Jersey in this time span. So our novices are noticing these peaks and these valleys. Those are surface attributes. Whereas as experts, we can notice those, but we can also kind of blur our eyes and look kind of across the whole spectrum to see this feature, this meaningful pattern of over the long term, there has been an increase in latitude where we are finding black sea bass. Part of this is that as a novice, we haven't chunked our information. Instead, it's all these disparate pieces of information that we have memorized or that we have learned, and they haven't yet connected together. And so as an expert, we have chunked our information. We can connect it around these big ideas. They're sort of stuck together, and we can use that stickiness around those big ideas to help us solve whatever is in front of us or help us think about whatever's in front of us. But when we're a novice, it's all these different pieces of information. And so we're coming at it and we're like, okay, we're looking at data, we're trying to make sense of things. And what we probably have chunked in our head is, ooh, data bar chart. This is a big reason why students love to make bar charts, why our learners love to make bar charts. That's great. They're actually using a mental model, a connection of data and bar chart, because we see lots and lots of bar charts, and we see lots and lots of bar charts early on. So we've had lots of exposure and repetition. So that is actually an organization of some of our information. But most of the time, our students are just sort of spinning through lots of different pieces inside of their head and just sort of grabbing at one and pulling it forward when they are coming to work with data, as opposed to us as experts, where we've got this sort of chunked around big ideas and we can pull from it. Because as experts, we have this knowledge chunked around these big ideas, we can flexibly and selectively retrieve from those big ideas what is relevant for the problem or the situation at hand. Whereas our learners who are novices are less likely to know what conditions they're going to need what piece of information or what experience they've had previously. So they're just grabbing. That's what I was talking about. They're kind of going in and they're being like, that one sounds good, as opposed to thinking, oh, okay, we're looking at sea bass over time across a 40+ year time span. We might be thinking about sort of this isn't annual migration patterns. We're looking at larger term shifts of the species. Maybe this relates to climate change. So we're looking over like at a time series. Maybe we want to look at a line chart. That's us flexibly and selectively retrieving information. One last key difference of how our brains work differently between a novice and an expert is that as an expert, novelty is nuance. It's what we don't expect. It's what's interesting. It's what's different or what is similar that we weren't exactly expecting or predicted. For our novice, novelty is anything they haven't seen before. So a new set of data, a new type of data visualization, a new type of data visualization with the data that they have seen before. All of these are novel. All of these are new to them. So they engage with that information differently than when we do as experts. This is really important to know as we are thinking about setting up a situation to support our learners with success with data. Their eyes go to different places, they pay attention to different things, and their brains process the information differently than we do as experts working with the data. So that's one big piece to think about when we're having our students work with graphs. Another is, dun, 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 how should we have our students make the graphs? Should they be doing it by hand? Should they be using technology? If so, what technology to use? So many questions. And there's some important things to think about, some benefits and some challenges of the different ways that we can make graphs. So like everything, it's not black and white, but let's think about these benefits and challenges. So graphing by hand. Lots and lots of graphing by hand gets done in the K-12 system. And there's some really strong benefits. It creates a personal connection to the data. You have had to physically put that data point, that bar, that line down on paper. That eye-hand coordination is so invaluable for that personal connection. We're often working with small data sets because, let's be honest, there are just only so many minutes in the day, so there's only so much time we can devote to actually making the graph. So usually it's a smaller data set, which for our younger learners is really good. For our novices working with data, a smaller data set is good. And as I mentioned, this hand-brained, eye-hand connection coordination is really helpful. It's similarly to why handwriting and cursive is really important for our brain development. But there are some real challenges with graphing by hand. It is time consuming. It takes a lot of time to make a graph by hand, right? And there's varying levels of ability in our learners of making a graph or making different kinds of graphs. It's really hard to make a pie chart with wedges that are not in, say, quarters, right? Like it's hard to sort of know exactly what angle that is. That's really tricky. It's a lot harder than, say, making a scatter plot or a line plot on our bivariate data. So graphing with technology also has a lot of benefits. It takes less time to make the graph because the technology does much of it for you. You can use a much larger data set because you don't need to plot every single data point yourself. You can graph it more easily in more different ways with just a click or a drag or a highlight of a different section. Poof, you can have a new graph, as opposed to going back to the drawing board, starting all over again if you want to make a new graph by hand. So therefore, you can more easily iterate. You can make different kinds of graphs. You can revise small things and adjust and tweak and edit your graph as you're going forward. And this is a workforce readiness skill. And so I know if you're going into kindergarten, you're not thinking about preparing your students for the workforce, but our middle school students, we should be thinking about it. And you know what? This is just a reality of living in the 21st century, that we make graphs with technology and we are exposed to graphs that have been made using technology. So that all sounds great, but there are also some challenges. It requires a Chromebook or a laptop that needs to be charged and needs to have access and things like that. You can have unreliable access to technology. One year, your school might have the license for that platform, that software, and the next year they won't. Where does that leave us with teaching our students on how to do it? Or you come back from the summer and it's a whole new piece of technology that you're being asked to use with your learners, and they don't yet know how to use the technology, and you're just trying to get them to make the graph for the work that they are doing. And tech can be updated in ways that don't make sense, don't align with your lesson plans or your units or things like that, or ways that you're familiar with. So it can get tricky. This is why it is great to lean on technology supports, excuse me, within your schools or your districts for support around the technology. But it also can be helpful to think of this as a continuum of graphing by hand to graphing with technology. So our younger learners are mostly absolutely doing their graphing by hand. And our older learners up in high school are mostly almost entirely doing their graphing with technology. And in that middle school, is that upper elementary middle school, is that transition of we're graphing by hand and technology, and we are moving forward like that. So a couple of things when it comes to actually making the graph and thinking about what makes a good graph. We're going to talk about this a little bit using some data on DreamWorks and Pixar movies, because that's fun. So we talked a little bit when we were thinking about exploratory versus explanatory data analysis earlier in the semester. And I kind of gave this nod towards like what goes in our title would be a bit different. If we are exploring the data, then it's perfectly fine for our title to be about the data variables. Remember, number of pitchers per team per game. For our movies, it could be movie budgets by year. Now, I do just want to point out that this title is telling us what the variables are, but so is the x-axis label and the y-axis label. So this title doesn't actually give us much more information, but that's okay when we're exploring, because we're just trying to get a sense of like what's in the data, what's going on. But when it comes to we have something to say from the data, that's when we want a different title. that's when we want the title to be something like Strikeouts on the Rise, where we've got the details of the interpretation. Movie budgets increased between 1995 and 2014. We are saying the claim, the conclusion, the takeaway message is in our title. Once we have done the exploring, we are now explaining with the visual. I make this case and sort of highlight this up because what I'm about to say in terms of what makes for good graphs is once we have gotten through all the exploring, like we've been doing this semester, and we get to the explaining. So everything I'm about to say is not worth harping on or paying lots of attention to when we're still doing our exploratory data analysis. But this is the aesthetic, how does it look kinds of questions we were talking about for explanatory data analysis. So number one, we want a descriptive title of what we want the people to walk away with. We also want to make sure that we've got a legend in a place that is easy as possible for people to see, either on the side or even better lined up with the data, that it's color coordinated with the data, things like that. We definitely want to make sure we've got our axes labeled, especially if they're not showing up in the title or subtitle, or if it's not immediately apparent. So let me re-say that. We need the axes titles if it is not clear what is on the axis. It is possible to leave the axis titles out. I promise you it's okay. It will be fine. Look on your news feeds. I guarantee you'll find a graph that does not have the title labeled, but yet you still understand what's going on that axis. So we want it to be detailed. We want there to be units. If it's relevant, units are in parentheses. This one, rather than saying time, parentheses, years, we can just say year. Time is one of those things where we can kind of just go by the units. But here, budget, parentheses, millions of US dollars is to give us a sense of what's going on with that. The tick marks along our y-axis and our x-axis, we want to make sure they are there, that they are labeled, that they're large enough that somebody could see, but not so many that it clutters our understanding of the visualization. So what you'll see here is that this has tick marks every 2 years. We could have done every 5, or you could have done 10, but then we would have only had 3 tick marks, and that would have been a little bit harder to understand. So you want to kind of find that like happy in between zone of like how many tick marks is enough to aid in understanding, but not so much that it is distracting. Okay. For our graphs, the origin, so the initial value on our x and our y-axis when we're using bivariate data, you want it to make sense for the data that you have. It is not always 0, 0. It would not make sense to set the y-axis, the x-axis here to 0 because Pixar and DreamWorks were not around in year 0. Okay, so you have to think about it. You have to be especially careful when thinking about it with bar charts because bar charts are showing a comparison of the difference. But if it is never possible to have 0 on whatever it is you're measuring on the bars, then that doesn't actually make sense to use the 0. But you absolutely cannot pick a value for your origin that manipulates the that like really dramatizes the difference or the lack of difference between your bars. So you want to go for something that like, what is a reasonable lowest value that you could use for your origin? But it doesn't have to be 0, 0. Ideally, we've bolded our axis lines. There's no background color in the plotting area. And unless you need it for analysis, for making sense of the data, it's better to leave off the grid lines. Those are the kind of background up and down lines. Now, for our younger learners, it can be really helpful to have some of those grid lines in to make sense, to analyze the data. So that's an instance where we would maybe want the grid lines in. But vast majority of graphs, we don't actually want the grid lines that show up in the default in our graphics using our graphing programs. So just sort of as a refresher, thinking about we want to scaffold, we want to do this transition on how we do different graphing from mostly by hand in elementary school to mostly with technology. As we get up to high school and this middle school, shout out for all of our middle school, this is the transition. Like many things in life, middle schools are a transition. And we think about how to make a good graph is what comes to play once we've done all of our exploring and we know what story we want to tell from those data. That's when it can be important. Okay. So thinking back on these components that we've just talked about, what excites you about teaching graphing with your future students or teaching your future students how to graph? And what could you use from this mini lecture that we just talked about to help you in your teaching of your future students how to graph? So pause the recording, think about that, and then come back. Thank you so much for all that preparation work, all that planning work that you're doing to get ready for your students, to help them thinking about graphing and making graphs going forwards. If you have any questions now or once you get in the classroom, please use my contact information and reach out. Thanks so much. Happy graphing.